So the next quadrilateral is a kite, all right? And it's a little more complicated to construct this one, but we're going to do it real quick. And what I do is I start with a circle, right? And what I'm going to do is draw one side of the kite. So I'm going to draw this side right here. Then what I'm going to do is plot a random point down here, which is going to give me the opposite angle of it. I'm going to draw a circle to this point here. Now what happens is I have two different radii in this, so I'm going to mark this intersection, and if you think about it logically, when I construct this segment, I know AC and AE will be congruent, and when I construct this segment, because circle D is there, I know CD and DE will be congruent. So now I'm going to just go hide some objects here, right? Only because it's hard to see, right? But this ends up being our kite. And right away, how do I know it's a kite? Well, if I measure these sides, right away you get one pair of congruent sides. When I measure these sides, I get another pair of congruent sides. Now, real quick here, just by the definition, you should recognize that when you create a kite, are opposite sides congruent? No, right? Were the opposite angles congruent? We still have to determine that, all right? But were adjacent sides congruent? Well, we could say there are two pairs, right, of adjacent sides congruent. So let's look and measure these angles here. So I'm going to go ahead and measure this angle. I'm going to go ahead and measure this angle, and finally this angle. Now, can we say, is it right to say that opposite angles are congruent? And the answer to this question is, right, no. Okay, so when I look at it, we could say one pair of opposite angles are congruent, right, but not both pairs. Now, how do we identify which ones? Well, I'm going to say where the vertices, where the two non-congruent sides intersect, those angles are the ones that are congruent. So were opposite angles congruent? There was only one pair of opposite angles congruent. And it was the vertex where the non-congruent sides meet. All right. And when you look at the adjacent angles, they are actually neither of these. Okay. When I go back, I'll talk about that. So when I look here, these don't add up to 180, these don't add up to 180, these don't, and none of the adjacent angles are congruent. But what I'm going to do is I'm going to move these measures out. Okay. And right away, what I'm going to do is I'm going to construct one diagonal and start off with that. Just like a rectangle and a square, right? When I construct this diagonal, what I want you guys to notice here is you end up getting, what you end up getting is this triangle ends up being isosceles, and this triangle ends up being isosceles, right? This is one important part to help you with this. Now, when I draw this one in, right? Now, I do not get isosceles triangles here, right? But when we look at this, right away, it says construct the diagonals. Are they congruent? Well, first off, do they look congruent? No. So I'm not even going to measure them. I'm just going to say, no, they are not congruent. All right. So when we construct a diagonal that connects the vertices where the two non-congruent adjacent sides meet, what type of triangles does it break it up into? two isosceles triangles. So when I draw this kite and I go ahead and I draw this diagonal in, these sides are congruent, so that's one isosceles triangle. These are congruent, that's the other isosceles triangle. Okay, so now when I construct the other diagonal, right away, do the diagonals bisect each other? You'll see here when I plot a point at the intersection here, right? Do the diagonals bisect each other here? These do, right? But do these get bisected? No. So when we talk about this, what's the best way to describe what diagonal bisects each other? And what we're going to say, no, only one diagonal is bisected. And I represent it as it's the base of the isosceles triangles is bisected. So if this is the base of my isosceles triangle, when I draw that other diagonal in, these end up being congruent. All right. Now, when I look at the intersection of this, right, and I measure that angle there, right, that ends up being 90 degrees, telling me, right, from here that the diagonals are perpendicular. So right away here, you'll always get a right angle in the middle. Okay. So what is the best name you can give the diagonal that connects the vertices of the two congruent adjacent sides? When I look at that, it is basically the perpendicular bisector. All right. Now, right away here, when you go and measure these angles, all these other angles, always remember, use the idea of the isosceles triangle, that if sides are congruent, angles are congruent. So as I look here and I put these measurements, right, these base angles of the isosceles triangle are congruent, and these base angles of the isosceles triangle are congruent, which means these bigger angles are congruent. But when you go to measure these angles, there's really nothing there. Okay. So these, although their opposite angles are not congruent, those are congruent, which means when I measure the other ones, these end up being congruent, right? So when I look at it, it's like one of those things where you have to know what angles end up being congruent, and using the isosceles triangles and the fact that you have a perpendicular bisector, there's a lot of things going on with a kite. And again, I like to logically think through a kite versus trying to memorize all the properties. Okay, so when we look here, right, in this kite, right, we want to find angle 1, angle 2, and angle 3. Angle 1 is the easiest because you know that these create a right angle. So angle 1 is 90 degrees. Now angle 2, right, if I think about it, now I'm going to use this triangle. And to find angle 2, I'm going to do 180 minus 90 minus 32, right? And that's going to give you 50 8 degrees. Well, you know that this angle is congruent to this angle, so angle 3 right away is 32 degrees. All right, if not, you could also say this is 58 degrees, and then in this triangle, 180 minus 90 minus 58 gives you the measure of angle 3. All right, in this next one, right, find the value of the variable. Well, right away here, I know those are 90 degrees. Okay, so how could I go ahead and find x here? Well, if they tell me this angle up here is 3x, since you know these are a right angle, what I'm going to use is I'm going to use this triangle here. Because if I look, now that I know that's a 90-degree angle, now I know 2x plus 90 plus this angle here, 10x minus 6, all have to add up to 180. This 3x ends up being a distractor. They want you to be able to determine what angles you're going to have to use. So 2x plus 10x is 12x. 90 minus 6 is plus 84 equals 180. Subtract 84, 12x equals 96. And x is going to be equal to 8. All right. In the next one, if we know the definition of a kite and they tell you these sides are congruent, to find the value of x, you're just going to set those measures equal to each other. So when you solve this, you get 6x equals 12, x is equal to 2. This is the distractor in this problem. Okay? Go ahead, try the homework, and let me know if you have any questions.